Yeah.
Perfect. Well, welcome everybody. We are made it to our December meeting. We're looking forward to Anton doing a presentation on large acoustic airspace and its impact on thermal performance. Before Lee, can you get us started with um, prohibited topics?
Yep. Include prices, markets, output, collective refusals to deal, strategic or business plans, restricting competition. Discussion will be stopped and the meeting will return to legitimate business if any of the prohibited topics listed above arise. If the discussion continues, the meeting will be stopped and the matter referred to legal counsel. Attendees should voice their concerns if improper discussions arise. If necessary, attendees should leave the meeting and request to have their objection and departure noted in the meeting minutes.
Super. Do you want to review the meeting minutes? Does anybody have any questions or comments on the meeting minutes? I think it was fairly straightforward. Um, yeah, so we'll just keep going. I'll
So
motion to approve.
good. And then a second one?
Yep, good.
Okay.
Terry, and we're good. All right. Super. Well then, on to you, Anton. Glad you could make it. If you want to do a quick intro and just head right in, that would be perfect.
Yeah, so for those of you that don't know who I am, kind of been in the building envelope, building science industry for the past 25, 30 years. Worked a fair bit in window manufacturing, more in the vinyl industry, but with a heavy focus on multifamily development projects. So my background is working with architects, engineers, builders, developers, reading specs, dealing with contracts, all the technical aspects that we've had to navigate in our industry over the past 20 years or so. So a lot of my background is in the Pacific Northwest, BC. So I tend to take a lot of focus in regards to kind of what's going on in BC as a bit of a pre-indicator as to what could be going on across the entire country into the future. So this topic, when it was approached to myself, and some of the other discussions we've been having at Fenestration Canada about acoustics and some of the issues that are caused around it, it sort of started to open up some additional conversations and some of the challenges that I've personally experienced over the past 10, 15 years as acoustical consultants have become almost a normal occurrence on projects. And I don't really have a presentation today. I wanted to make it more of a discussion. I have a sort of some data I'm going to share here in a little bit, but I wanted to give a bit of a background as to why this conversation I think is critical at this current stage of our industry. And if you talk to architects on projects, when we're dealing with sort of complex multifamily projects, whether it's a 30-story high-rise, six-story wood frame, on projects where there's basically part three buildings, where there's a large dependence on expertise, professionals, consultants, you'll hear comments from many people that we've never seen more consultants in project design than ever before. As a result of that, it's increased the demand of coordination. And if we look at the role traditionally of the architect on a project, the term that's often used is the coordinating registered professional. And that's an important aspect of this conversation going into acoustics and thermal performance, because these are two items that have to be coordinated. And when are they coordinated? Who coordinates them? Who determines what's going to work, what's not going to work, and where there's potential conflicts that sort of come into it? So I'll back up once we once we establish that the coordinating registered professional plays a key role. Many of you probably have experienced reading specifications, glazing, fenestration, window specifications. You can probably spot content in them that might go back 20 years. So there's unfortunately a lot of cutting and pasting going on with specs. There isn't always that project specific coordinated level of specifications, which triggers some of these issues that we're going to talk about. So going to the beginning stages of a project, what I'm going to talk about here is how many different consultants and design professionals are specifying an IGU in a building. I think the first part is to recognize, what we could do in regards to specifying, the glass makeup, the airspace, the overall IGU. So an architect on a project very early on at the development stage of a project is going to lay out the facade of a building, which generally is going to determine the frame to glass ratio because, let's face it, fenestration's become architectural. So we're using, whether it's aluminum profiles, vinyl profile, whatever it is, we're using the profiles to create architectural features on a building. When we factor in the idea of project-specific thermal modeling, that becomes an important conversation because the glass that's going to go into that building to get the overall U value is going to be, specific to that building. The U value of a building, of a window for a building, depending on which jurisdiction you're in, if you're in British Columbia, it's being determined at the zoning stage by energy advisors, energy modelers at this stage. So the U value we all know is going to dictate what the IGU is going to be in a window as well. So you can start to see here now that the architectural design, the energy requirements, and then you bring in an acoustical consultant and they're going to specify an IGU in two ways, either to meet a performance metric, an OITC number, or they're going to give a prescriptive IGU layout, certain glass thickness, certain airspace. So now we've got an architect, an energy advisor, an acoustical consultant that is all determining what an IGU needs to be in a building, and they all have their own specific agenda that they have to meet, their own area of professional practice that they have to sort of identify and take responsibility for. And then an architect will go write a specification. And unfortunately, there's too many specifications where there's a glazing spec, there's a window spec, and they're not coordinating the energy criteria and the acoustic criteria into that specification. The project goes out for tender, it lands on the manufacturer supplier's desk. And unfortunately, the general contractors will send you the spec, the drawings, the acoustic report, the thermal modeling report. They'll send you all of these documents and say, it is your requirement as a manufacturer to meet all of this criteria, which is what I call kicking the can down the road. Now you become, as the supplier, manufacturer, you become a quasi-coordinator. They're expecting you as the manufacturer at the tender stage to determine what is going to create conflict and not conflict. And that's where we start to see issues start to bubble up in regards to when is the appropriate time to bring up these conflicts between different IGU designs. Is there enough time to? And I just did a presentation to an architect here in BC a couple weeks ago, and we were talking about, or the architect made a comment that they are expecting the manufacturer to provide boundaries and feedback in regards to what their product can and cannot do. To which my response was, when are you giving them the opportunity to provide that feedback? After you've designed the building, at the tender stage, at the contract signing stage, when is this all occurring? And so really what I'm digging into here is coordination is the key to success when it comes to these types of issues that we're kind of running into. 9 times out of 10, there's no conversation that occurs. The projects are tendered, bids are qualified for the most part, because we all know in the industry what we can and cannot do. And then you get to the table where you sign a contract. And unfortunately, this is where I would say be cautionary with some of this. When a contract references the specifications, the drawings, the acoustic report, the energy report, they start throwing everything into the contract that puts the responsibility now contractually on the manufacturer to meet these expectations for these performance. And so this is where the risk part sort of comes into play. And then once you sign the contract, the next stage is to do shop drawings. And this is where we get into engineered shop drawings. This is another classification where I say we're kicking the can down the road, because the specifications that the architect wrote are going to require the manufacturer to have engineered shop drawings, which is generally for structural purposes only. Now, the fenestration structural engineer, let's say, has to design windows for wind load, guard load, combination loads, attachment. And if we're designing windows for guard load, guess what they're dictating? What glass goes in that IGU. So now we've added another professional to the IGU specification, but only to do this after contracts are signed, once all designs are put forward and laid out. And then one of the last things we do, which is starting to become more and more common, is we request that the manufacturer provide project-specific thermal modeling, which is now going to start to incorporate, go right back to the beginning, where the aluminum to glass ratio, or the frame to glass ratio based on the center of glass and all the different U value criteria is going to start to play into the situation. So you can see the complexity now when it comes down to is, what is the IGU that's going to be required? What glass thickness, what type of low E, what spacer, what type of spacer material? Is it double, is it triple glazed? How is this all going to impact the overall coordinated design of the entire building. And that's really where we're at in an industry right now, is the number of parties that are dictating or designing or providing input into what the IGU makeup needs to be. They're not actually sitting around the table and coordinating their designs together. And so at the end of the day, all of this responsibility for meeting the expectations of performance from acoustics, thermal, and structural, I'll throw that one in there, life safety, who's taking responsibility for it? And this is where shop drawings really start to play a significant role, is when you do a set of engineered shop drawings, you're dealing with the structural life safety. You can reference the project-specific thermal modeling at that stage. You can identify what the IGU needs to be at that stage in order to meet the critical life safety component, and then flag when other issues aren't met for acoustics. And I'll share a bit of a story I have at the end of this conversation where I had a situation where acoustics was being picked over life safety, which was a big kind of red flag. So I'm going to share my screen here a bit, kind of dig into some data here that we've been sort of calculating. And most of us that have been in the industry long enough know that when we, hang on, I'm going to assume everybody can see this. When we change the spacer width of an IGU, the U value adjusts, it changes. And I don't believe everybody in the industry is aware of this issue in the design community, and it's being addressed accordingly. Everything that we've done, we've optimized in our industry at about a 1/2 inch airspace when it comes down to doing our thermal modeling results. And so what I did here is we played around with therm, and we looked at basically spacer widths going all the way up to 21 millimeters, all the way as narrow as about a 6.5 1/4 inch type of thing. And looking at it, just a typical curtain wall system with a Lamy combination. The data in here, it's just picked out of therm. It doesn't matter what we did because we don't really care what we're actually modeling from a U value perspective in the material, but we're actually looking at what's the relationship as the airspace changes to get either wider or narrower, and what impact does it have on the overall system's U value as it changes. And so when we work with acoustics, and anybody who's ever seen an acoustic report, we'll see that they're generally written in two different versions, or with two options available. The performance option, which is listing the OITC level, and that can range from 28 to 34, sometimes up to 35. And then they'll request a copy of an acoustic test report to validate it, or they might provide another column where they actually dictate the glass thickness and the airspace dimension that they feel is suitable for achieving that acoustical requirement. So it's sort of similar to a Part 3, Part 9 combination in the code, where you have a design metric versus an actual prescriptive criteria. So in my experience, what I've seen recently is with densification coming to society, meaning more people living in a smaller location, acoustics is becoming more critical. We're seeing bigger buildings built along busy corridors. We got a lot of street noise. So in the concept of achieving an OITC 34 in a window for a bedroom is becoming a common occurrence that we're seeing, especially in the Vancouver market. Kind of a typical window you would see specified at an airport type of thing, if sort of putting into perspective. And the prescriptive layouts that I've seen provided by acoustical consultants is to either use a 21 or 19-ish millimeter airspace with a Lamy combination glazing system as sort of a prescriptive method of achieving that result. Now, if you've ever done any acoustical testing, you'll also have some of your own understanding of what it would take for your product to get to that level. And so the challenge with this is we know in the industry that when we start making our airspace bigger, we start introducing convection currents into the actual cavity, and it starts to degrade the U value. And how much does it degrade it has always been the open-ended question. How much do we lose it by? And you can see here the system is optimized at about a half-inch airspace, and as we get to 19 to 21 millimeter airspace, you're starting to see a loss in the overall system U value from, this is including the frame and the edge and the center of glass, where the Lamy-Lamy combination at center of glass, you can see from a 1.34 goes up to a 1.45. That's with no other changes to the system other than the size of the airspace. The opposite is also works as well here. Is as you get narrower, you can actually see there's a significant degradation in U value as you try to put thicker glass into a glazing pocket that you might not be able to change. And this is where some of the challenges occur, is when you see specifications to use thicker glass, Lamy-Lamy, but the Windows glazing pocket may not be able to accommodate an overall thickness of an IGU. The common trend is to shrink the airspace to about a 1/4 inch, which you can see the impact that it has. The other option is to start considering a window in this realm where you've got, 21 to 19 millimeter airspace with Lamy-Lamy combinations, where you're actually getting up into the 34, 35 millimeter IGU, which is basically the width of a triple glazed IGU, but it's a double glazed system. So these are some of the issues that we're seeing sort of bounce around when it comes to how to coordinate these aspects. The reason why I show the center of glass impact versus the whole system impact is because when you start getting into project-specific thermal modeling and you get buildings with greater glass to frame ratios, the amount of glass and glazing you have and the amount of airspace you're going to start putting in is going to start to impact what that project-specific calculation is going to start to look like. So where our industry starts to run into challenges with this is, when is all of this being sorted out? When are we addressing this issue? Is this a design issue? Is this an expectation put on the manufacturer to have a solution for it all? In my personal experience, this is a coordination issue more than anything. And because the reason why it's a coordination issue is because the conflicting issues we have, it's basically coordinating registered professionals and ensuring that the overall design of the building allows those registered professionals in charge of a certain aspect that they can accomplish what their goal is. Because at the end of the day, registered professionals, whether it's a structural engineer, an energy advisor, an acoustical consultant, they've been hired onto a project to achieve a certain outcome. The responsibility for them to sit at the table and have a conversation about coordinating their requirements and their outcomes is crucial. And I would say the missing component in that conversation is they don't know enough about windows and glazing systems like everybody in this room knows right now. And it's not like they're hiring the fenestration industry to sit at that table. I used to work in Seattle for a number of years, and I just had lunch the other day with a large window wall manufacturer in Canada who also does a lot of work in the US. And we both agreed that the beauty of the US market is they do these things called design charrettes, and they will actually hire a glazing contractor, a glazing manufacturer, just on an hourly rate to sit at the design table at the early stages of a design of a building to basically say, here's what we want to do. Is this actually manufacturable? Can you actually build this? Can you actually make it work? Can you coordinate this? And they'll get direct feedback from industry at that stage. In Canada, for some reason, we don't do that. I think it's because the US has a very high litigious industry, and coordination is how you reduce, the risks associated with the project. And so they just have a different culture, I think, in design, and they incorporate a lot more of this work into what we do. So, that's just a bit of the difference between the two. The story that I have that I tell a lot of times, it's from a 6-story wood frame building. It can be relative to any other commercial project that you do, but it's the idea that the project had an acoustic requirement to it that required Lamy glass with a 19 millimeter airspace. That was the acoustic spec for the IGU. The specifications required that the project have engineered shop drawings, so the manufacturer was required to provide engineering for guard and wind load of the glass that goes into the building. And then there was also a fairly strict U value criteria. It was a government housing project, so they were a bit more aggressive than code minimum. They were pushing the boundaries of what basically a double glazed window could do. We were pretty much tipping into triple glazing to hit the U value. But the problem was the acoustic design required lammy with a 19 millimeter airspace, but the U value is pretty much pushing into the need to go to triple. So you're kind of going, how do you quote this? What's the actual system that we're going to quote on the project? And knowing what I knew and knowing what I needed to meet for life safety going into it, we knew that the windows were below 42 inches from the finished floor. So the inboard light could not be lammy. It had to be tempered in order to meet the guard load. And I know in regards to code and what's required for acoustics, acoustic requirements from outdoor to indoor is actually not a code requirement. The National Building Code and the BC Building Code and pretty much every other provincial building code, when you read the acoustic requirements, it's for indoor to indoor, suite to suite, mechanical unit to suite, and it refers to STC. It does not refer to any OITC criteria. So there's actually no professional responsibility from a code perspective for acoustics. And so what triggers a lot of acoustics is municipalities will require developers to get an acoustic study done as part of the development permit for densification. And basically say, because you're densifying, we can consider acoustics to be an important factor, which it is. I'm not saying we're not going to do it, but when it conflicts with life safety, there has to be there has to be sort of a hierarchy here of importance. And so I'll always personally put life safety in front of acoustics when it comes to making a core decision. So the project is awarded, contracts are signed, and this is where you have to be very, very, very careful. Be careful how general contractors slip in consultants' reports that are uncoordinated into your contract. That is something to pay close attention to, and how you deal with that is going to be every single window company supplier's process and dealing with it. But at the end of the day, you have this process called shop drawings, and shop drawings are used for engineering, but they're also used for coordination confirmation, in my opinion, because the shop drawings will get stamped by the architect saying they've reviewed them and commented and provided feedback. They'll get stamped by the building envelope consultant that they've reviewed them for Part 5 compliance. The energy advisors will review them. Some will stamp them saying they've reviewed and approved, some won't. So that's something to be cautious of. The general contractors will stamp them. And then, of course, they're stamped by a professional engineer stating, addressing the wind loads and all the other life safety aspects that need to go into a window. The approval process of shop drawings, I'm not a legal expert on this, but they start to form the revision to what potentially was contractual. And in most cases, what gets flushed out at that stage is where the conflict occurs. So in my situation, the shop drawings were done. We showed 6 millimeter tempered on the inboard light, 6 millimeter laminated on the outboard light. The shop drawings were rejected. They didn't meet the acoustic criteria. And now what do? They meet life safety. So the solution there was, well, could we do laminated tempered? And for those of you that know what the cost of laminated tempered is, when you're trying to make buildings more affordable, it doesn't really make a whole lot of sense. And so the other aspect that came into it was the 19 millimeter airspace and then the U value impact. And long story short, a code consultant had to be hired for the project. And because the architect didn't feel comfortable making this coordination decision, and the result of the code consultant was outdoor to indoor transmission of sound is not a requirement of the BC Building Code. Therefore, the acoustic criteria can be omitted from the design, and that life safety and energy basically are in the code and were required to be met. And so therefore, we could basically move with tempered on the inboard light, laminated on the outboard light, maintain the half-inch airspace in the IGU for double glazing. Then we could then upgrade the low E coating, not have to go to triple glazing. And at the end of the day, we got a win-win. And we were about 3 OITC off what the target was. So we were pretty good still on acoustics, just not to that level that had to be met based on the precision of the calculation that was done. So it's not like you sacrifice acoustics completely when you do this sort of coordination, but it's the idea of knowing what that change is going to be and what's more important. You could sacrifice some U value, or you could sacrifice some acoustics, but you can't sacrifice life safety when it comes to picking your actual IGU system that goes into it. So that kind of is a bit of the conversation I wanted to bring up based on some of my experiences dealing with this in the past. And the thing to pay attention to is when you're bidding on projects, in certain jurisdictions, acoustic reports are almost guaranteed to be on a project. So if no one is giving you that document, or they just forward you the acoustic report as part of the tender process and you have to sort through it, be careful of the lack of coordination, because that's going to tend to sometimes fall on your desk in regards to flagging these issues and when is that opportunity to flag them. So I thought maybe I can leave it at there for now. And if we want to open it up for some conversations and more discussion, I'm happy to kind of dig through this a little bit more.
Wow, that's a great summary, Anton. Thank you for walking through that. Rich, I mean, early on you raised your hand. Do you want to have a comment while people are going submitting questions?
So that was actually just making sure that Anton was able to share his screen. So no, that's good. A great conversation. I have in my previous life experienced a good chunk of what Anton was mentioning. And yeah, the affordability, he nailed it on the head there. That was my biggest thing, is what does this all do to affordability?
Yeah.
But you answered that.
Yeah, there's a question there. What if a competitor can meet the acoustic and the life safety and thermal requirements?
This is my frustration in working with acoustical consultants is if you I've tried to have conversations with them, and their response is often, well, so and so window company can do it. And you're like, okay. So it basically, and the ones they're referring to are the very large ones with deep pockets that can afford to do a lot of testing. It's the issue with this comes into play in regards to the competitive analysis of the industry and creating an apples for
Yeah.
apples perspective of quoting. And the amount of effort and time you have to put in. Like there's one acoustical consultant now that I've been experiencing. They no longer provide prescriptive acoustic glazing options. They basically say if you don't have ASTM E90 testing of your product, we will not approve it. Full stop. So when you tender a project like that, if you didn't know that, right? If you weren't aware that they weren't going to accept that, and you were awarded a project, and then at the shop drawing stage, the requirement is to have these reports, and you don't have them. So, it's a very reactive kind of part of the industry. To do it in a proactive way, if you were to look at all the different IGU configurations that you could possibly make and had to do acoustic testing of all of those scenarios, like we all have done this on thermal, where you end up with 30, 40,000 different thermal simulations at a computer simulation level. But for acoustics, I've not experienced a simulation process for acoustics. It's all testing. And it is not a cost effect. It's not a cheap test to do when you do a lot of this testing. And you may not get the results that you like either when you ship your product down for testing. So, yeah, one company could have more than the other, and I think that's sometimes the challenge of it.
Nice. Adrian, do you want to comment?
Yeah, just wanted to speak to the ASTM standard. So, if you guys do get that in the future, ASTM E1332 actually calls out ISO 717-1 as an equivalent standard. So, if you've got an acoustic engineer that is beating on you about that, the standard itself actually calls out the ISO standard as an equivalent. So yeah, don't take that lying down if you've done one or the other. And I mean, there's a big conversation here. It's like the specification side of how you meet multifamily compliance is messy. Like I know we had a meeting, I guess early this year with contract language, and I was pretty strong on, you need to make sure your specifications are modified. Like if you get a specification from a GC, don't just accept it in full. You need to correct that per what is appropriate for your product for that project. Like if you're going to accept the project, you need to modify the specifications because they become contract documents, which is just as good as having to follow code requirements for a multifamily building. Like just because there isn't code requirements, but the specifications call out the requirement doesn't mean you can avoid the requirement. So.
Yeah, great. Thanks, Adrian. Otto had a question. Should you know what your system's limitations are with regards to all the criteria and qualify your bid?
I think that's a big question to know what all of your system limitations are. The important part is I would back up here and going, what are all the requirements that are going to be required of your product today and into the future? And how do you plan and prepare for that going into it so that you're aware of it as you go? And so this is sort of the as industry grows, as markets shift and change, and I can see it happening significantly right now in our industry where we're seeing wood frame go up to 8, 10, 12, 18 stories. You're getting the combustibility changes. You're getting vinyl and fiberglass systems moving into more combustible building categories. You're seeing a lot of fabricators graduate up into more complexity in the industry. And, for some, it's scary. And for some, it's what do I not know that I should know going into this industry? And from an acoustic perspective, my personal experience has been most learn it through by diving into the deep end, not knowing how to swim and scrambling and trying to sort through it. And the challenge with this is the point I'm really trying to make here is the ownership or the onus of solving this issue is not solely upon the manufacturer to have all the solutions. It's a really important part for the coordinating registered professionals to coordinate this because the motive of a developer on a project is to have multiple bids from a competitive perspective, which basically keeps, trades and pricing in sort of a level of control. And if all the bids start coming back with qualifications, this is going to start to change. The developers are going to start asking, how come every single window quote or quote I get for fenestration has got a qualification to it? It's usually because of a lack of coordination. And so the question is how do we work with design communities to set our specifications up within the boundaries of what the industry is capable of doing that keeps opportunity still open for industry to have fair and equal balance of opportunity that goes into it. So yeah, it's one of those, you could actually probably put it into like kind of an equality and equity conversation here. Yeah, the more testing you do, the more your boundaries start to open up, right? Or the more you know about what your product can do. It's a double-edged sword, though. Sometimes the more you know what it can do, puts you in a position where, how to navigate the world of tendering projects and qualifying bids and then having the conversation prior to signing a contract in regards to it. So I think it's important to keep the conversation flowing and get a bit of unity in the industry that you can't just arbitrarily increase the airspace of a window and not expect other things to be impacted and to be able to educate designers on the back end. So when you're in a situation at a shop drawing stage or at a contract signing stage and you're saying, unfortunately, we can't achieve that 19 millimeter airspace because the U value that's been specified requires triple glazing, and I can't accomplish that. And so being able to advise general contractors who then have to bring that information back to the architect, at the time that that's occurring becomes sort of the critical issue here. So yeah, to answer Otto's question, knowing your boundaries of your product is important. But it's going to get to the point where if everybody knows the boundaries of the product, you're going to find projects where there's not a single glazing system that's ever going to work. And so they'll get to a time when a project will get 0 bids, in my opinion, because of the lack of coordination. The more everybody knows the boundaries of their product. And then you're going to get general contractors basically picking up the phone at an earlier stage and saying, hey, can you review this to make sure that it's actually going to work? And they're going to ask industry for input. And that's going to come from one manufacturer, not from a group. And so this is where the issue kind of comes into play in regards to universal understanding of product ability versus a manufacturer-specific ability to meet a certain aspect of it. So it's a complex world and a complex spec. So
Anton, I want to dig a little bit deeper into the testing conversation. As you mentioned, there's nobody currently that's offering this in Canada. You're going to the States and most of them are the States. So it's extremely expensive, especially if you want to do more than 1 or 2 products. I don't believe there's a certification requirement anywhere for acoustic testing, certainly not in Canada. Model sizes, I don't think so. You test whatever you want to test, and hopefully that's what you're going to sell. Um, when you look at, okay, I'm a manufacturer and I've got, a handful of tests, maybe for, a casement, a picture, a fixed window, maybe a combination, if I'm creative, what's the impact when you start taking those numbers and applying them to a more complicated multi-light design? Are we again throwing out numbers like we've been doing with U values for decades that are not realistic?
In my experience with there's I don't believe there's any gateway size criteria for acoustic testing that allows an acoustic report to be compared from an apples to apples perspective. It's not like you don't have a NAFS gateway or an NFRC gateway size. So does glass to frame ratio impact acoustics? Does having mullions in a window impact acoustics? I would say most of the acoustic reports that I've seen are just a picture window, a casement window, an awning window, a sliding window. Um, crack length of a sliding window, in theory, would have an impact on acoustics because air leakage is one of the biggest culprits when it comes to acoustics. So, the bigger the window you test, the worse are you going to get a worse number? Is it a smaller window? And how are we evaluating that? So that's number one, is I don't see there being any consistencies from one to the next. The other issue that I've seen is the prescriptive data that acoustical consultants have been using for years and then tested results, they're way off, in my opinion. I've seen certain criteria where they said, well, this IGU makeup will mean an OITC 34, and the test reports I'm seeing come back say 29. And I had a conversation with one acoustic consultant, and he goes, they must have done something wrong in the test. And I'm like, well, how do I know? How do we even know what, like, I packaged product up and shipped it down to Texas, and I came back with a report type of thing. So it's not
Yeah,
like I can
yeah.
go to the facility and witness like a water test and see what's going on and see what we can do to R&D it and improve it and how to tweak it. And the other question I had is your prescriptive criteria based on a piece of glass and a wood buck? Is it based on a rigid aluminum frame? Is it based on PVC fiber? Like, does a PVC frame create more of a vibration effect? What impact does that have? The information is, for the most part, there's very, very, very little conversation going around in regards to how certain window components affect overall acoustics and how to get apples to apples comparative analysis and data. Simply put, it's not a requirement of code. So when you
Yeah.
see how loose everything is in the industry, the requirement for acoustics was always a bit of a luxury item that you put into a house. And so most of the documents that you see most people working with kind of a bit more are on the marketing level where you talk about, how to overall, create an effect in a home so it has a beneficial effect to the lifestyle of people. So to be honest, I've never seen a combination window acoustic test ever done. I've never seen that. So I don't know if anybody's doing it. Be interested to see what is being done out there for combination windows. And if somebody could do can you do a weighted area calculation of acoustics like you do with thermal? Is that even possible? Can you extrapolate data to come up with information? If I did three different tests of one product series with different IGUs in it, could I extrapolate data in between the two? We don't have a tool for that. So, I've had some acoustical consultants where I want a test of the exact IGU that you're using, which we all know varies so much from all the different energy and aluminum to glass ratios when you get into project specific thermal modeling. So it's an endless world of testing
Yeah.
when it
Yeah.
comes down to it. So there would be an interesting conversation to have in regards to the ability to take, let's say you had 5 or 6 data points of acoustic testing on a certain product series, and if you could then extrapolate something in between so that you weren't always so dependent on testing as the only solution to compliance. So
Yeah. Yeah. You and I have had a lot of conversations along with Adrian on the durability, sustainability conversation. You know, all of this 6 mil, 6 mil lammy going into these casements, hanging out there, you know, are we just asking for another problem when we start having issues with operators that can't manage, the gloss that's going into them to hit these numbers.
Yeah, if you look at some manufacturers will publish their acoustic data on their websites, which I appreciate because it gives you some data points to reference. But if you start looking at the OITC 34, and that's where I really say once you get over OITC 30, between 30 and 34, you're seeing some pretty crazy IGU assemblies. 10 millimeter laminated glass, 8 millimeters, 4/6 on 8, triple glazed. And I'm doing the math on it, going, this thing won't fit in an inch and a half, an inch and 3/8 glazing pocket. I go, it won't even fit in a window. So I'm like, is it a fictitious IGU? Because it's unglazable in a product, unless you can get some crazy window systems with, modifiable glazing pockets like you could in maybe curtain wall, some assemblies where you can adjust them. But in punched window openings, pre-manufactured assemblies, the question then comes into, if you do that, what does that do to your thermal modeling results? What does it do to your NAFS results? Because now you're modifying the product to accommodate an acoustic glazing system. So like the rules we have in our current standards in the code limit how we deal with acoustics. And I don't think we have the conversation enough about why it's important, or why we should not have regulations that are bylaws. And I tell this story all the time. It was 2014. I was coming across the ferry from Victoria back to Vancouver, and I'm in the buffet lineup having dinner, and the Minister of Housing just happened to be standing beside me, like ironically, and Rich Coleman. And he was in my riding, so I kind of knew him. I've met him before. And I go, hey, Rich. And we started talking, and it was right when the BC Energy Step Code came into BC. And what was happening is every municipality was writing their own energy code at the time, and it was chaos. Every single jurisdiction was declaring climate emergencies. They're like, we need to do this, and every builder's freaking out. So the Home Builders Association came together and figured this out, and we came up with this universal energy step code of step 1 to 5. But it was clear there's a roadmap in front of everybody. And at the same time, though, he said to me, he goes, I have taken all authority away from the municipalities from the building code. And he revised the Building Act that basically said it's illegal for municipalities to have their own bylaw. And why that's critically important is because when a municipality requires it in a development permit now that there's an acoustic study done, what happens when that design conflicts with code criteria, which is what we're seeing. And that's why it's important that you don't have bylaws that are separate from the building code, because for the most part, the building code is well coordinated already. It gives you the process of coordination. But when you throw in this sort of acoustic uncodified criteria into a project that people feel is equally important, unfortunately, it's not. It can't be. And so we have to have this sort of perspective that acoustics is a nice to have, and we get as best we can, but we're not going to get 100% of the expectation if we have to meet everything else. How we qualify that in a bid, how you qualify that in your contract, how you build awareness to the industry. I hate to say it, but that's literally one of the reasons why I went into independent consulting. So I can sit down with an architect and say, you can't do that. I fortunately get hired onto projects at sometimes the development permit stage. So I can actually look at that, and I can look at an acoustic report, and I can say, there's no system that you can build that way. And then they're like, oh, well, what do we do about it? I'm like, okay, let's put a pause on that and have a conversation. So that's personally what I'm trying to do. It's issues like this that have raised awareness of the need for how do we have these conversations early and stop kicking the can down the road for manufacturers to have to sort out for everybody else. Because I think it's so unfair to ask a manufacturer to deal with this when it is the architect's responsibility at the end of the day. So that's my goal personally for the industry, and why I like talking about this topic, because I think it's so needed. So,
Well, that's a great goal. Very appreciated. We just had a comment from Omid he said, for your information, the BCIT Acoustics Research Lab has both acoustic simulation capabilities and ASTM E90 test chambers, allowing us to assess transmission loss and overall acoustic performance for various assemblies and fenestration products. So that's great. I actually didn't know that. I had gotten quotes
Yeah.
all over the US.
Brent, if I can jump in there.
No.
Sorry.
Yeah,
Sorry,
go
I
for
was
it,
going to
Terry.
say,
Yes, sorry, Anton. So we've been having some conversations with the folks at BCIT, and we're going to be putting together a facility tour with them and their acoustics lab for FenCan members, etc. Probably sometime in January. We're hoping to see where they're at and to let them hear from the industry as well on some of the challenges that we're faced
Yeah.
with on acoustics. Very, very exciting to see BCIT, getting an acoustics lab that will be available for manufacturers to test their products here in British Columbia, in Canada.
Do we
Fantastic.
know, do we know if it'll be like a certified test facility where you can get like ASTM E90 reports coming out?
That they're working towards that, yes.
Cool. I'm just going to say I can see the building from my window here. It's literally right across the street from me. So
Nice.
one of the things that we've done, we do at JRS because we're so close to it, is they have a master's program at BCIT that deals with building science in their master's degree program. And one of the areas I wanted to touch into was this idea of thermal and acoustics as a master's project for a student to take on and do a deep dive study of the overall impact of large airspace windows, especially from a durability. As you go to a 21 millimeter airspace, is the IGU durability? What is that? What does it do to that? And start digging into that conversation too.
Yeah. I just wanted to share this photo. It was something that I shared with Anton. It's probably a couple of years ago now because we've been having this conversation. I was traveling. This was at a hotel. The jets were less than 100 yards from my window. And you can see this. This is an aluminum PVC system with a dual glazed half-inch unit on the exterior and then a single pane of glass. And it was about 3 inches in from that sealed unit. I could not hear the jets out that window. It was incredible, the acoustic performance. And again, airspace is everything when it comes to acoustics, right? So
Yeah,
that-
that the Fairmont at YVR is the same thing. And I remember when that building was built, when I was going to BCIT at the time, and we did a field trip of that building, and I believe the airspace in that IGU is 2 inches. And same thing, it overlooks the runway, and you can't hear the planes. And the conversation I remember we had was at the time we didn't have energy codes that was critical. And so they basically sacrificed thermal performance for acoustics for that building, and they chose acoustics over energy. That was, and so it just shows you at a time when there isn't thermal code requirements, there's a lot of flexibility in what you do. And then, going back 20 years ago, if you wanted an acoustic window, you put in a traditional thermal window and then you put a piece of glass 2 inches in. That was the way it was for so long. And then we kind of started hitting good acoustic numbers, OITC 28. So we're like, oh, we can do this now in a double glazed window. And it wasn't until we started pushing to OITC 34 where we started seeing some conflicts start to occur. So yeah, the history of acoustics and glazing is actually kind of a fun little topic to study because if you look at what was done in the past to where we are today, we've all kind of created this problem in a roundabout way. And then we pushed the boundaries to the point where we broke it. So it's kind of reset a little bit is where we need to go. So.
Excellent. Excellent.
That's great. Any other questions? Or, I mean, experiences that people have had? I mean, I think one of the questions is like when we're dealing with curtain wall, is it coming up with curtain wall? I know it's a little bit more focused on the residential side, but on the commercial side, have people experienced that? There you go. Anyway, I mean, we had it come up a couple times, and
Yeah,
and
you're going to hear
definitely
it
makes
more
a
and more
headache.
as we densify. There's no question that this is going to become a bigger deal. So again, to reiterate, watch your emails for information about the tour that we're going to be doing at BCIT in their acoustics lab in January. So keep an eye out for that.
That's great. Well, I want to say thanks so much, Anton. I really appreciate the conversation. I think, not whatever, 5 years ago, I wish I had this conversation of just like how it fits together. And definitely had some hard experiences kind of along the way. So really appreciate your time and bringing these issues up. Thank you so much.
You, Jeff.
Awesome. I think the rest of the meeting, I mean, this is actually my last meeting where I'm hosting, chairing the meeting. I want to, thanks everybody. It's been great being involved with it. I mean, I'm just felt my business is kind of transitioning into some other things, and I've decided to focus in on that. But I really appreciate working with FenCan and Terry and Rich. They've been fantastic, and the people we met along the way. So yeah, thanks so much for the opportunity. If you are looking for in getting involved, you're like, wow, people need to know about how to navigate these issues. I know FenCan is looking for people to be involved and
Yeah,
help kind of steer what's happening. What's the conversation? What do people need to hear about? So
for
yeah,
sure. We're anybody interested in taking on the chair role of the commercial chapter, just reach out to any one of us. We'd be happy to have that discussion with you. It's not a huge drain on your time. Mostly organization and some conversations about activities and what we want to try and focus on. So anybody interested, please reach out. I did want to mention, just as we start looking at 2026, that our third annual Canadian Glazing Conference is scheduled for April the 8th at the Park Hotel in Vancouver. Just about got my education lineup dialed in for that. So watch for that. That'll be coming out soon in January. And then I'm starting to work on FenCon Winnipeg for April the 23rd. So watch for information on that. It's going to be a busy year, 2026. I can already
Terry,
see that we've got a lot going on.
can you just highlight some of the conversations that you're aiming for CGC? Give people a little preview.
Let me see if hang on a second here.
I mean, maybe it can be subject to finalization, but
Yeah,
it's
for
always
sure.
nice to
I
know.
don't want to give away too much, right?
Okay, fine. Well,
But
might
no,
okay.
fair enough. I've got we're going to be doing a session on job site lean practices. I'm working on a session for overheating in passive house projects. We're also going to be hearing from Shiva Zargar from Build Neutral, sharing information about the city of Vancouver and carbon reporting that they are now requiring. So yeah, got a few good sessions already dialed in, and I got another really good one that I think that I've got confirmed, but I don't want to give it away. It's going to be the leader for that event. So yeah, I'm just about dialed in on it. So
Great. Well, we'll stay tuned.
But
Okay.
just want to highlight again, though Terry mentioned it. So it is a new venue. It is a bigger space at the Park Hotel in Vancouver. So just so everybody gets that, and wanted to thank you too, Brent. Awesome working for you. You stepped up when we launched the commercial chapter a couple of years ago, and you've been a phenomenal chair, and you're just a natural at it. Sorry to see you go, but totally understand it. And yeah, it's been awesome working with you. And yeah, look forward to the next chapters.
Well, that's great. Thanks, Rich. Okay, that pretty much wraps up the meeting. Thank you, everybody. Yeah, looking forward to seeing where it goes from here.
all right, thanks
Have a
everybody.
great week.
Thanks, Anton. Great
Okay,
session.
yeah, thanks very much.